now slice the brain and the brainstem and the cerebellum and arrange serially. We will identify the structures in each. Here is the anterior part. Here we can see this is the space is here, that is the anterior horn of lateral ventricle, and going backwards we can see this nucleus that is pushing, almost pushing into the lateral anterior horn of lateral ventricle, that is the caudate nucleus. The caudate nucleus will always be in relation to the lateral ventricles. And this is the internal capsule, the anterior horn of the internal capsule. Then going back, we can, here also we can see, and this is the septum pellucidum. This is corpus callosum, cingulate gyrus, corpus callosum, cingulate gyrus, the septum pellucidum. This is the fornix, caudate nucleus, and coming down, we can see here, this is the lenticular nucleus. The lenticular nucleus is consisting of putamen and the globus pallidum. Together they are called the lenticular nucleus. And this here is the third ventricle. The space here we can appreciate, that's the third ventricle. The lateral ventricle goes into the third ventricle through foramen of Monro, and then here we can see that the caudate nucleus is decreasing in size as we go backwards. And here we can see the septum pellucidum. This is the internal capsule, and this is the putamen, and together the caudate nucleus and putamen are called as striatum. That is because this internal capsule here gives a striated feeling, striated look. The fibers look striated here, so together they are called striatum. Then here we can see the hippocampus. This is the hippocampus. This is the insula. Insula is the part of the cerebral cortex that dips deep into the brain matter. This is the insula. And as we go backwards, we can see the caudate nucleus has become very small, almost unable to visualize or difficult to visualize. And this large structure that we see now, that is a thalamus. Remember, the caudate nucleus is always in relation to the lateral ventricle, and the thalamus is always in relation to the third ventricle. And as we go back, and this is the posterior limb of the posterior horn of the lateral ventricle, and what we see here, the structure is called the choroid plexus. Choroid plexus is what produces the cerebrospinal fluid. In the from the lateral ventricles through the foramen of Monro, the cerebrospinal fluid goes into the third ventricle, and from the third ventricle through the aqueduct, this is aqueduct, through the aqueduct of Sylvius, the CSF will flow into the fourth ventricle. And that is it here. Now we'll go to the brainstem. This is the midbrain, and this what we see is the substantia nigra. Here we can see the red nucleus. This is the aqueduct of Sylvius. This is the pons. Pons, you can see the decussation here, pondine decussations, and this pigmented, blackish pigmented area is called the locus ceruleus. And then we go to the medulla, and here what we see, this is the olivary nucleus of the medulla. It will be a little difficult to appreciate, but that is the olivary nucleus of medulla. And here this is the cerebellum that is arranged on either sides, and this is the crumbled appearance, that is the dentate nucleus, the largest nucleus of the cerebellum. Cerebellum has fovea, the cortex is arranged as fovea. It's very easily seen. So this is the dentate nucleus, the fovea. And as for the sections that we have to take section from the superior and middle central gyrus and frontal gyrus, superior and middle frontal gyrus, that we have to take a section, that is the watershed area between the anterior cerebral artery and the middle cerebral artery. Then we have to take sections from the basal ganglia area, from the hippocampus. The whole of the hippocampus has to be taken. Then we can take a bit from the midbrain. In case of Parkinson's disease, the substantia nigra won't be seen like this. The pigmentation will be decreased grossly. You can see, take sections from the pons, then from the medulla, and also section from the cerebellum, which includes the cortex of the cerebellum as well as the part of dentate nucleus. Okay, that's it.